From the heart of Dubai, where tomorrow is being built today, to the world. Welcome to the CTO Show with Mehmet. Here, we redefine technology and reimagine possibilities. With Mehmet, delve into the riveting realms of AI, cybersecurity, and digital technology. Experience the thrilling highs and lows of startups. Immerse yourself in the spirit of entrepreneurship and witness the future of business innovation being written in real time. Now, without further ado, let's tune in and explore the future.
Hello and welcome back to an episode of the CTO Show with Mehmet. Today I'm very pleased. Joining me, Luv Kapur. Uh, you know, the way I love to do it, my guests, all of them, they know about it. As I keep it to my guests to introduce themselves. But Love is technology leader at Bit. We will talk with Love today about multiple topics. So we're gonna discuss, of course, composability, high performance teams, maybe buy versus build also as well. Of course, we're gonna talk about AI, and like a couple of other topics about engineering. But without further ado, Love, thank you again for being here with me today. What I love to do always is I give it to my guests to introduce themselves, tell us more about you, your journey, and what you're currently up to, and then we can start discussion from there. So the floor is yours.
Thank you so much. It's a pleasure to be here with you, Mehmet. I'm an engineering lead at Bit. At Bit, we build an end-to-end platform for composable software. Previously joining Bit, I've led platform teams. I was a engineering lead for a platform team in a fintech company where we had tens of 20 to 30 developers working on internal tooling. And our goal was to make sure teams can develop software faster and more efficiently. So I've always had a love towards dev tooling, as much as I love working directly on the product, but watching my work empower developers who are helping build these products has been very satisfying. So my career has been mostly working with dev tooling, working on platform teams, building internal systems. And that's how I got into composability and Bit, where I was actually one of the first enterprise customers for Bit when I was in platform lead. I got Bit adopted across the entire enterprise. And once my work was done, I joined Bit so I could, bring the power of composability to more than just one enterprise and to a larger group of, whether they're startups or other enterprises itself. So now I work both on the open source and the enterprise software for us. And I also directly deal with customers as a solution architect, understanding, how the integration goes once they adopt Bit itself.
Great. And thank you again, Love, for being here with me today. Now, kind of a traditional question, I would say. So for the audience, tell me more, what do you mean by composability? Of course, of myself I know, but this is just to kind of demystify things, and modular architectures, and what you know draw you to adopt them. And maybe you can talk to us also about the benefits that clicked really for you.
Absolutely. And before I start, I think, thinking about composability as just a software architecture pattern it's way more than that. It's an organizational operational model. Every time I tell people about composability, I tell them to envision about Lego. Lego and also think about how how manufacturing went through the whole consistency, where we have now how we can quickly build manufacturing itself. And the core concept about composability itself, it's that you need to build into these individual, modular, reusable, highly leveraged units, which will help you scale very fast because there's consistency, and there's quality. And what it helps you to do is build systems. It helps you to scale systems very independently without being blocked. One of the key issues I see a lot of organizations face as they scale, their engineering department and their engineering, headcount itself is starting getting coupled internally, getting blocked. And then this is where composability shines. Where composability says is you think yourself as you're not building a feature in a system, but you're building a system of features. It's the other way to think about it, where each artifact you produce as part of the development process is at the end is an asset. And that asset can be used, can be leveraged, can be rebuilt, and anything you do in future can utilize the asset you have built. It's not throwaway itself, which has a tremendous impact. The consequences of this is that subsequent as you iterate on your software, as you build your teams, as you move forward, as you scale, things get faster, things get more consistent, things are able to deliver sister. So the core concept again is you decouple yourself, you build these highly modular, reusable artifacts as part of the development process. You organize yourself as team. If you think about composability at an organizational level, in the same way where each team is completely independent, they own end-to-end systems. Their systems can easily get integrated within internally and can build on top of it. And then the subsequent delivery of these systems features or artifacts keeps on getting faster because you build on top of them at the end.
Cool. Love if you can give us example, because you mentioned like there are parts of Legos. So let's take a small organization that maybe they have, let's say sales, marketing, HR, and I don't know, maybe they have finance, right? So just I'm trying to explain it like in a very simple way. So instead of building a system that has all these things together, and then correct me if I'm wrong, and then when try to add features, so maybe you do something, you affect the whole thing. So rather than building module for finance, module for HR, module for sales, and then you keep iterating and enhancing each one by itself, and then you can scale the whole system together because you have this modular approach. Correct me if if I get it right.
No, you're right. You've got the gist of it exactly. And the thing I try to emphasize on is you have to stop thinking in terms of deliverables internally, like, oh, finance needs to build a dashboard for us to be able to visualize, what are we spending on? Or analytics needs to go in and build a dashboard. And you take a step back and the organization thinks, what capability do I need? To build that capability, what needs to be shipped to be able to have the capability internally. Then what does the capability do? That's the contract of a modular software. Oh, it needs to be able to display some stuff or act or fetch some stuff from somewhere or organize stuff or group stuff again. And then you build this capability as a part of a reusable module. And then you think about it of who will consume this capability. So in terms of, let's say, if you're building a deliverable or a capability for finance, you understand what my customer in finance are going to use for, how are they going to implement it? And then if they have to extend it or customize it, how can they do it directly? So you bake in the capability, thinking of a more holistic approach to approaching it, and then you ship. Then you own end-to-end of this capability itself. And then I use the word capability very loosely because when you translate it into actually a deliverable, there's a lot of pieces that goes on behind it. There's data extraction might be going on. There's an API server that might be going on. You have UI that gets getting built on top of it. So you try to modularize everything into a single unit, and then you ship. And then you make sure there are clear contracts on how it behaves, how it extends. What this empowers you to do is now you understand as an organization at a given point of time what my capabilities are. When you start having these discussions, when product managers start getting into these meetings and deciding, hey, our stakeholders are asking us to build X feature. How can we ship this? You're not playing a guessing game. This is where I think a lot of software teams struggle, where estimates are very, very hard because non-technical people trying to understand how much time it takes to ship a technical piece of deliverable, there's a disconnect. And there's nothing to blame on the non-technical user. There's a disconnect because from a non-technical perspective, understanding what it takes to ship something technical, there are gaps, there are unknowns they don't understand. But once you start thinking of capabilities, and hey, last quarter, these are the capabilities we shipped. This is what it offers. Now, can we build on top of those capabilities? Can we extend stuff? Oh, we have done this in Q1 already. Let's take that system and build on top of it. Now you're having more intelligent, more accurate conversations around this. So this has that impact overall when you start working through composability.
Great. Now, there's another concept, or let's say it's a common term. We hear it a lot, Love, which is, high performance platform, right? So, in your experience, what do you really defines, to say like this is a high performance platform, and how does the composability enable that, in your opinion?
I have a few. When everyone talks about high composable platforms, the foundation of it is actually the impact you get out of it at the end, and the impact you
Mhm.
can get out of them is the lead time getting reduced? And what I mean by lead time is like when someone asks you for a feature and you deliver, and then someone asks you for a subsequent feature, you deliver. Are things slowing down or things getting faster? Things should always be getting faster because every time you deliver something, you have built a building block to step on top of it and reuse its ability. The other one is the adoption spread. This is one of the biggest issues I've seen within internal organization is if the team is not high performing, they struggle with adoption. You can build the absolute perfect piece of software or absolute perfect system. If your users cannot seamlessly adopt it, you have failed at the end. It's not a success. So adoption spread and adoption speed is very, very important. The other indicator of a high performance culture or a high performance team is the ability to understand defects. Will shipping at scale, will shipping more features introduce a lot more defects or reduce it? If you go through, if a high performance team actually is building stuff through composability, the amount of defects will go down as they ship more. Because again, the building blocks they're using are battle tested. These are pieces of software that are in production already, that have tests, that have unit tests covered, that have integration tests covered, that have end user testing covered. They've lived through all the phases of testing and you're building building on top of it. And the last piece, which is very, very critical, is how is the developer sentiment within the high performance team? Every individual in the team should feel empowered. Every individual in the team should feel that their contribution is visible across. That's what empowers developers to become high performers themselves. And at the end, I tell this to organizations all the time, the most valuable asset you have is the people. If the people itself feel that their sentiment is good, they feel empowered, they're delivering, and they can see they have visibility on their impact. Your culture fosters a lot of high performers itself.
Right. Now, the question I would ask you as maybe follow-up question on this one, um, I would say, and I know, like you said, you use it, in a loosely way a little bit, but uh, we see a lot of companies, they want to go into this, and achieve that through modularity, reusability. But when it comes to execution, they kind of hit a wall, right? So what do you think the biggest is? It like, let me ask it this way, is it like because some misconceptions they have, or like other reasons that really these companies, they really they wanted to adopt this way, but maybe they implemented, or they tried to do it in a wrong way? In a nutshell, like what goes wrong? Is it misconception? Is it like wrong execution? And why this wrong execution, in your opinion, happens sometimes?
From my experience, the one of the biggest reasons why companies fail for adoption is because a lot of composability comes from a top-down, approach, where
Hmm.
from the top, the executives itself, like, what one of our mandates, especially technical executives, will be one of our mandate is to make our organization composable, our systems more composable, and they try to enforce it from top down. It doesn't work top down because the problem is it's an organizational shift that needs to happen. It's not just a technical shift that needs to happen at the end. And systems are, especially in large enterprises, they're legacy systems, they're complex systems. And companies are always, especially technical people that are maintaining the systems, are risk averse. No one is going to rewrite a system to become composable. No one is going to change the way they're working from top down to adopt composability. The teams that have been successful to adopt composability have been from bottom up, where you start with a single product or start with a single system. And I'll take an example of design systems itself because it's very easy to follow a design system example. So the best part, the right approach is to actually pick a product in a system that you internally use. Your customers are internal itself. And then you start adopting composability from that system itself, and then you make your way up. You pick a product, you pick an internal system, whether it's a design system, you build it in a composable way, you measure it, you reuse it, you add lead time, then you build a central catalog. Once you have a central catalog, you have empowered discoverability. That's another piece where companies fail, is they don't understand that for composability to succeed, discoverability is key at the end. And the reason discoverability is key is because one of the biggest pitfalls when companies go for a composable adoption is fragmentation happens. There's no consistency. When you can build these highly modular components and there's no consistency across how are they being built, that you cannot compose them at all. So, and if you don't have visibility on what exists and what doesn't exist, so from your company's perspective, if me as an engineering leader can't understand what capabilities that exist, what they do, and refer to them, and I cannot discover them, then it will lead to duplication. It will not be the perfect way to go about composability itself. And then once you have started from bottom up, you've taken a system, you built it a composable way, you have measured it, you have built a catalog. The third step, which is very important, is you need to empower ownership, where end-to-end ownership of the system have to be empowered completely. Maintainers need to have guidelines on this module as I own it and how to contribute back, how to extend it. And then you go on to enable inner source. Inner source is the last missing piece. To truly, completely reuse composability, you need to have a culture of inner source. All the software in this world is being built on the backbone of open source. Open source has done tremendous things. The reason we are here is because of all the success we had from open source. The only downside of open source is, for enterprises that have closed source software that have, very specific needs, open source not always works. But what works is the principles of open source implied internally. So your systems and software you build, how open source builds it, if you build inner source way, now you have a catalog, now you have discoverability, now you have ownership. And then the last piece to just tie it up is you need to reward the reuse part of it, where you celebrate teams that are using shared asset. You measure teams that are building on top of the existing assets. You encourage teams to go back and enhance these shared assets again. And we can dive into more specifics of the implementation because there are various approaches you can. A lot of companies, one of the ways that companies approach it is a home and away model, where you split your teams into a home team and an away team. So you pick a team who you want to start bottom up that needs to use composability. You split them in home and away. The home team is responsible for building this reusable, highly modular system itself. But again, if you go back to the conversation I had, you can build the most beautiful system. If no one adopts it, or if they have painful adoption and integration, then you're not successful. This is where the away team comes in, where the away teams will take the system that's built by the home team, join one of the partner teams, help them with integration, learn all the stuff, contribute back to the home team. And now you have this nice system within the organization that fosters this.
Cool. So this requires also kind of, if organization didn't have this yet, so they need to have this cultural shift internally, so everyone will embrace, this concept, right, Love?
Yes,
Right.
absolutely. Yes.
Right. Now, I would like to, see tangible things that maybe you can share when it comes to results, right? Because I know, you talk about like how, this, of course, you mentioned about, the collaboration and, the ownership and the transparency. But when it comes to like more tangible results, like, have you measured, like, for example, how much faster, for example, a product, start to get shipped, or like how more stable the product would become, maybe, less number of bugs. I don't know, like, maybe you can highlight about some tangible metrics also. Maybe this is for leaders who want to adopt this and start to measure the impact of adapting this in their organizations.
Absolutely. And that's the backbone of composability itself, is the results are very, very tangible. One of the few things we have seen that in iteration cycle, so you won't get, this is very important to get clear, is you won't get the benefit of composability from step one. It takes time. It takes time to, start reaping the rewards of it. So if you start building composable systems for, I'd say, Q1 itself, what we have noticed that subsequent features in Q2 start taking 25% less time to build. Not just they take 25% less time, because the reason is because you're reusing what you have built in Q1. They also, what they do is they reduce the amount of defects, because the more amount of new code you write, the more probability of introducing defects increase, because the surface area increases. This also ties back to the topic of composition versus generation in AI, and we can dive into it later. But this is the reason: the more code you generate, the more code you write, the more defects. So we've noticed defects start going down at least by a third, 33%, as you start composing more. The biggest advantage which we noticed, which we wasn't expecting, this was a surprise for us when we started measuring this, is the power you get, adoption to composability, is liquidity in headcount. Headcount is one of the most valuable assets companies have. Headcounts is stuff you will see departments fight over, where you have limited amount of headcount, you have unlimited amount of requests coming from your end users. You have priorities shifting because of whether they're macro factors. Let's say you're going through a time where compliance is very important, and priorities need to shift accordingly. And then you ask yourself as an organization, how quickly can you move headcount from team A to team B without impacting performance and still deliver fast? In a non-composable organization, it's very, very hard. The reason it's very hard is because teams have very different ways of working. They have very different ways of developing, very different ways of software. There's no visibility at all completely. If I pick a person from team A and put them in team B, the wrap-up time is so much that you don't start seeing the benefits of headcount liquidity. But through composability, since these are modular systems, there's discoverability, there's standards baked in, there's visibility itself. Now, as the demands of the business change, I can pivot. The business feels they have the superpower now, where I can take X amount of people from team A and move to team B, supercharge them, deliver them, and then move back. I can change the structure of my teams very dynamically and organically within the organization itself, based on how the needs change. So these are the biggest tangible benefits we have seen. There's the iteration cycle, there's the speed of delivery for subsequent features dropping down, increasing, the defects going down, and then this mobility in headcount, the liquidity, we call it, you get, for leaders to be able to reorganize themselves according to the change in the needs itself.
Great. Now you mentioned AI, and of course we can't skip talking about the AI. So what role AI can play, here? Is it like, the from enhancing the process itself, maybe help in suggesting how they should, I'm not sure if this is the right word, even modularize what they have in place, or is it like kind of, just helping the developers on the bit that they would be using? So if you can open this more, about the role of AI in this whole concept of we were discussing about composability and modularity, if that makes sense.
Absolutely. This is one of the my favorite topics to dive into, because AI is having such a big impact in the world. I wasn't there when in early 2000s when internet happened, and that was amazing for technology, because it ended up transforming everything, and we are going through a similar period. So it's very exciting. So if you take a step back and you think about what AI is, and specifically we will talk about large language models that have become popular, they are generating text in a probabilistic way. They are probabilistic machines where you ask them a query and they will generate something for you. Developers have adopted them to be able to speed up the development process, where you don't have to write software as much as manually as much. You can generate a lot of it. And the adoption has been crazy. But if you take another step back and think about the direction large language models are taking development into, you start noticing a pattern which doesn't sit right. If you ask any highly technical person in an organization, is the bottleneck for delivering software faster is to write more code? Most of them will say no. It's not a
Mhm.
bottleneck. I don't need 5 hands to be able to faster deliver software. My hands are not a blocker for me. The blocker for me is to actually be able to understand a complex problem, build, put it into an architecture, and then deliver it. That's the hard part. But every AI software is going down the generation route. The generation route has a lot of pitfalls because that means that um, every developer is generating code that looks different. Every developer is generating more code than existed before. That means the surface area for defects increase at the end. Which will not scale. It might work for a small one-person startup or a two-person startup that their bottleneck is actually headcount itself, where they don't have enough people and they want to supercharge yourself. But for large enterprises with thousands of developers, this will create a big mess. You don't want to give AI, to 1,000 devs and let them go make it a Wild West and say, go ahead and just start generating code and contributing back. This is where composability comes in, is where we, as champions of composability say, you want your AI to be an orchestrator, not a generator. Think about it. Your developers have built a lot of valuable intellectual property internally. And I said intellectual property, I'm talking about the code that's been written. When new features need to be developed, I really don't want AI to generate brand new code. I wanted to have invisibility on what exists. Again, we go back to the talking about capabilities again. What capability exists? What needs to be built? What is the gap? What can I reuse? What I can build on top of it? So I only need to build the delta between what exists and what doesn't exist. I don't need to regenerate everything at all. So once you start using large language models through the lens of as an orchestrator, as a composer, we call them a composer or an orchestrator, then a generator, now you're extracting immense value from large language models, because not only now developers are shipping more high quality software that has been battle tested, but now when product managers come into meetings and they start interacting with the internal large language models, it has a complete context of what exists internally. It has context of what has been delivered, what can be picked from what has delivered, and how it will impact the future delivery itself. Um, that is the real power of AI, and this is where we think the future lies, especially for the adoption of AI in large enterprises itself.
Cool. I like what you said. We don't need to generate more costs because, yeah, I think, and back to your point about open source that you just mentioned before, and I think, of course, this is a cumulative, I would say it's a heritage of all the work that have been done before the age of AI, all the people who have, created these repositories and, they created all these, frameworks, right?
Yes.
And the templates and so on. But still love, and maybe, I'm just, kind of wondering and, seeking answers from you. Um, and this is maybe applies more to new teams or startups rather than bigger companies. So maybe they, and it's better to do it early. So if they can do the modularity, the composability early, it's better for them because this will help them to scale better also in the future and about the performance as you said. But maybe they would need also some best practices regarding maybe choosing the good technology to use, maybe the right platform to use. Do you see AI also kind of acting as a smart consultant, or I don't know, like maybe um and kind of architect that gives them, okay, like for this use case it's better to use this framework and that framework. I'm going to the nitty gritty a little bit here because expectations from AI are very high. Are we there yet? Do you think AI would be able also to advise on like what technology fits us better, like what kind of architecture we should use, which languages, which kind of databases will fit us, for example? What's your
Abs-
take?
Absolutely. I think we're getting there. We're close, especially if you look at the graph on how quickly AI is improving. Um, uh, is absolutely mind blowing to see how quickly the changes are. So I think AI can absolutely play the role of a consultant and an architect that can actually do the guidance part of it. The reason is because it's trained on a lot of good work, like you talked about. The heritage of open source. That's one of the main primary source of what AI has been trained on. So if you're starting fresh, and if you're a small company, and you're trying to understand which direction to approach for a given piece of problem you're trying to solve, the AI will do a good enough job to guide you. Where it gets even more useful is for larger enterprises that have already taken a direction already. Let's say, they picked a framework, they picked a language. Now, what differs from, a single person startup or an indie developer versus a large enterprise is not only you have all the standards that are open source, you have internal standards that make sense for you to scale. A 500 to 1,000 person development team cannot just go with an open source, just a framework, and then expect that it scales. For everything to work cohesively, they have developed internal standards for them to be able to contribute and develop, so they can consistently develop at scale. This is where the AI can play a very powerful role itself. That if it understands your internal capabilities, if it understands your internal development standards, and it can help you and guide you in the right direction to keep those internal standards and improve on them as you scale, then you're reaping a lot of benefits from AI stuff.
Right. Love, I figured out on your website you have a platform, you call it HopeAI, that exactly does what I was asking you about. So tell me a little bit more about this AI component that you have at Bit.
Absolutely, this is one of the most exciting things I've ever worked on. HopeAI is one of the world's first composable AI software, where it works as a role of an architect. Instead of a code generator. It's not a code monkey, is like I call it. Its goal is not to write a lot of code, is to write intelligent code for you, guide you into the right architecture. One of the biggest differences between Hope versus other large language models, or Copilot and everything else, is Hope has the context of your entire code base, and not just one code base of your organization's code base itself. We call it a dependency graph. When you ask it something, it has an internal dependency graph that it lookups to. So if you come, as an organization, you've adopted Hope, and you ask it to build a feature, or you take a screenshot, its first instinct is to say, hey, I'm going to take a step back. I'm going to look at the dependency graph of what the organization has built. And then our dependency graph is very intelligent. It's been structured in a way that it knows what teams are there, what they're responsible for, what components they own and they maintain, what API of each component is that it can extend and use. So all of this information is baked in to the Hope AI itself. So when you ask something to Hope AI, its first instinct is to take a step back, look at the dependency graph, and propose an architecture. And see, this is the difference, where when I ask a large language model right now, it will just give me an output. Then I have to go back and tell it, this is not what I wanted, maybe this is not correct, or give it more context. Hope says, I'm not going to do anything. I'm going to do a proposal like an architecture does. It will come up with, these are the components I think you need to build. These are the components I think we can reuse. These are the components I think we need to enhance. And this is how we need to enhance. And then it gives you this architectural plan at first go. And then it can ask you to say, can you review it, please? And then you review it yourself. You said, this looks good, start. And then it gives you an option for each component. You can add, you can start modifying the individual prompts itself for each one of those components. So you get fine-grained control. First, you get control over how the architecture gets. You propose, you review. Then you get control over how individual pieces of this architecture, when they will implement, will be generated. And then Hope starts generating those complete architecture. And Hope is capable of not only building, just the front end, it actually builds end-to-end systems completely, whether it's databases, APIs, it will deploy it for you. You can review it with teams. We have a whole review process you can go through. And Hope shares the same workspace like you. So if the agent is working and it makes a change, you can just go to the same workplace, make a change, and the agent picks up. It's like, oh, we both of us are working as collaborators on the same workspace. So your code changes get reflected immediately on what the agent is working on. And that's what shines. This is very unique about HopeAI. Is this, it's one of the first composable AI architect that works through composability itself.
Very cool. And as I told you, like this is, it caught my eyes when I was reviewing the website, and I decided also to bring it to the topic here. Now, how much of uh, I would say um, success have you seen in the enterprise? Up, when is there a success ratio? Like, is this something that always succeed with enterprises when they go for composable systems nowadays?
Absolutely. Success has been very transparent. So a bit our largest customers, we actually do a ROI study with them. So we look at tangible benefits they have got at the end. It's not just about adopting the next fade or next craze that is in the industry. You need to see actual tangible benefits. Our biggest customers have stayed the same in 8 figures amount of money.
Mm.
These
No.
are the teams that have thousands of developers that are building thousands and tens of thousands of components over the course of the last 3 to 4 years, let's say. And they have taken a step back and they've done the rate ROI study with us, and they put a value to it, and it's in 8 figures. I can tell you the amount of money and time they have saved. This is just the money they have saved. This is not even talking about the quality of the output they have gone. And these are the companies that started with us with a team of 10 developers building hundreds of components. And 4 years
Wow.
later, we have thousands of developers building tens of thousands of components with us on the same. So, that speaks volumes to the amount of value they
Exactly.
got immediately.
Yeah, I'm a number driven guy, so when I hear this, as I like to hear these stories, and the way you measure the value proposition, I would say. Now, moving ahead, love, like, how do you envision the future of platform development? Right. So we talked about AI. There's a lot of things that are going around AI also as well. Of course, no one has a crystal ball. I know this, but with everything we saw in the past, I would say 3 years, let's say, right? Since, of course, LLMs have been there for longer, but they started to explode in the since 2022. Where do you think we are heading? I would say at least in the near future. I would not ask you about 10 years or like long term.
I think we are, and this is the best guess I can make from the facts we have in front of us. I think we're speed running towards democratization of software itself. From all this while, if you look at 10 years ago, there was a new trend that picked up, especially when I was part of these enterprises leading platform teams, no code tools, citizen
Mhm.
developers. This was the biggest thing because the company, large enterprises have a lot of non-technical users that are working with systems they want to control or modify at the end. And these are internal systems they're building. My experience mostly has been with large financial institutions. I work with a large pension fund. We manage hundreds of billions of dollars in money movement a year. And we had portfolio managers. And I take an example of portfolio managers that are highly intelligent. They're dealing with billions of dollars in software. We are building internal custom trading solutions for them. At some point, they understand their domain so well that they want to take control of the piece of software stack and make changes
Mm.
and do stuff. Um, then we moved on internally. What as part of the platform leadership, we started developing a citizen development platform for them to enable them, where built-in data pipelines were giving them the data they need. Built-in UIs were letting them to build UIs and let them go, give them freedom to express themselves and start building stuff that makes them useful. That scaled for a little bit, but that had its limitation with itself because again, you're dealing with non-technical users. This is what I see is what's going to happen is citizen developers are going to be able to contribute 80% of the as much as current technical developers are able to do. They will feel the sense of freedom within themselves now, where non-technical users within large enterprises are able to now control the softwares they are using, which are built by technical people. They're able to contribute back and make a real tangible change to it on how it affects their own workflow. Because large language models are going to make software so much more accessible for non-technical users itself, and that's the thing. I think that's the next big craze we will see is the empowerment of citizen developers from just not being citizen developers to be actual developers that are working on technical stuff they're using an end-to-end basis.
But we will need to have the engineers, right?
Absolutely. That I think that's not going away. Every time someone tells me that AI will take all software jobs, I ask them, is there a limited pool of the work that needs to be done? If you work in a large enterprise, we have always more work than you can do. Absolutely more work you can do. The reason you don't work on the other stuff is because you don't have enough people to be able to do it. So you don't focus on those problems. What AI will do is it will free the highly technical people to work on more highly complex problems at an enterprise scale. The problems will not finish. They will just get more complex and more technical, which now will become more achievable, which were not achievable before. Because again, to build a complex software, it takes time and cost. You reduce time and cost, that doesn't mean that the developer goes away. It just means the more amount of work can get done and more complex work can get done.
Right. Yeah, since my opinion also as well, because there's and people forget about it, is developers, I mean engineers and everyone, but I'm biased because I'm an engineer also as well. So there's the creativity part, right? Which yeah, I can think with you as a co-pilot as you described it, and we know this, but AI will not go and find new ideas to go work on, or maybe it would not, be able to be as creative as us. I know I'm not sure if in the future this will change, but at least my interactions with you know uh, development leads, CTOs, everyone I spoke with in the domain, even the most people who are into the AI, that they will tell you like AI is going to be everywhere. They agree with me that yeah, AI would still have this. You know, it's gonna be a co-pilot, but we need still the human brain and mind to get new ideas, find new problems to solve. And as you said, like always, we can find work to do, and AI will just make this easier. And maybe we can give the AI, the less demanding tasks which are repetitive to do for us. So absolutely agree with you, Love. Now, as we are almost close to an end, any final thoughts you want to share, Love, and also where people can find out more and maybe get in touch with you?
Absolutely. The last thing I would say is everyone should be excited for the time they're going through with AI and large language models. This is one of the most exciting times in humanity we can go through because of how the good impact is happening. And I'm looking forward to it. I'm looking forward to see what teams and companies build with this, leverage it. To reach out to us, bit.dev is our open source website. Bit.cloud is our enterprise cloud where I work and I build these composable systems, and HopeAI exists. You can reach out directly, check out what we built, see if it works for you. If you want to reach out directly to me, love@bit.dev, you can reach out, or you can connect me on LinkedIn. And I'm always happy to have a conversation on, composability or LLMs or any other things. And, again, thank you so much, Mehmet, for having me. It was a great conversation. I had a great time.
It was my pleasure, Love. And this is, for the audience. I will put the links that Love just mentioned in the show notes so you can, find everything, the website, his LinkedIn profile, and the email, of course. And again, I would love to thank you a lot, Love, for today. I also learned a lot about composability, reusability, and how organizations, small and big, they can leverage this. And as you mentioned, you gave us the ROI and how much savings can be done. So I love to hear these stories, and thank you for sharing that with us. And of course, I'm a big fan of technology. I'm an engineer, so hearing from experts like yourself is always a delightful thing for me. And this is for the audience. Again, if you just discovered us now, thank you for passing by. I hope you enjoyed. If you did so, please give me a favor, subscribe, and share this podcast with your friends and colleagues. We're trying to make an impact. So the more we get people, the more we can reach and leave the impact. And if you are one of the people who keeps coming and again, thank you very much for your support. Thank you for the feedback you sent to me. I read every single email you sent, so thank you very much for the encouragement also as well. And thank you for making also the CTO show with Mehmet always charting this year. I'm repeating this since the beginning of 2025. We've been like charting in the top 200 charts in multiple countries this year, and this cannot happen without you. So thank you very much. And as I say, always stay tuned for a new episode very soon. Thank you. Bye-bye.
Hit that subscribe button, share the show with your tech-savvy friends and fellow entrepreneurs, and leave us a review on your favorite podcast app. Your support means the world to us.